Hello, everyone, and welcome to our webinar from Theory to Implementation, Agentic Architecture in Generative AI. I'm Jitu Ganji, founder, CEO of TechGrid, and I'm your host today. We are going to deep dive into one of the most exciting shifts that's happening in the Gen AI systems design space, nothing but agentic or compound AI architecture. So we have Satish Therala, who is lead resident solution architect from Databricks, who would be walking us through the theory to the implementation steps, what, how, what, why, how, and then some of the tools and the patterns, as well as the real-time productionizing these applications. This is a 45-minute session. We are going to focus on the structured theory to the implementation, as well as after that, we will make it interactive. So feel free to drop in your questions in the LinkedIn Live or the Zoom chat, wherever you're comfortable with the relevant to the topics. I will be picking up, and then I'll go ahead with the Satish there. With that, Satish, please introduce yourself and go ahead with the topic.
Sure. So, hey, I'm Satish Therala. I'm a solutions architect at Databricks. My work primarily involves with building AI, start with like classical ML AI applications. Nowadays, a lot more work is around Gen AI and, relevant Gen AI applications, primarily using Databricks as the foundation platform. So,
cool. Satish, do you want to go ahead, deep dive into, there are some engineers to the tech leaders are there to get them into the topic. Just go ahead with what are these agentic architectures and the story behind it to begin with.
Maybe I should just share my screen and show you a couple of slides. It'll be easier to kind of, understand if you don't mind.
Okay. Yep, please.
Yep. Are you guys able to see my PowerPoint?
Mm-hmm.
Okay. So I think, what is today called as agentic architectures, the academic term for is what is called as compound AI systems. We call it agentic AI. But I think the origin literally is like, somewhere around 2022, 2023, we started seeing what are called LLMs, or large language models. If you guys go back like a couple of years, the most exciting thing about LLMs was how amazing they were at generating text and answering questions, right? You would ask it to, write a poem, or ask a question. It will just basically give you an answer as if you were talking to a real live chatbot or a person, so to say, right? So those are your first generation, or what are called as LLM applications. But soon developers started building applications on top of these LLMs that could actually do something useful. When I say useful, what I mean by that is not just generate answers, but also actually use the answers to do coordinate tasks, collaborate with other things, and like get some stuff done, right? Those probably are what we call the advent of generative AI applications, or what came to be known as compound AI systems. I think one of the first use cases that came out that everybody was impressed was, you could hook it up with your vector database, and suddenly it was able to answer questions from your documents, right? That's an example of an agentic AI, or a compound AI system. So the LLM, not just being a standalone thing, is now working with a database containing your documents, and is able to answer questions out of the document itself, right? The second thing is something like the Google's AlphaCode, where it generates millions of lines of code, and it is able to basically, spot check itself whether the code is going to compile, whether the code is going to run properly, if that is the most efficient way of doing it, and then give you an answer, right? So these are some of the early examples of what agentic architectures are. Back then, we didn't call them agentic. They were just LLMs using something else. The first term that came to be known as what are called as compound AI systems. There's a really good paper by Matej Zahari and a bunch of other people. And if you search for compound AI systems, they'll talk about the evolution of LLMs and then the compound AI systems as such, right? So at a very high level, an agentic architecture or a compound AI system literally is an application that uses LLM as the core of its brains. And we'll get into some of the details of how does it use an LLM as a core of its brain. But an application that uses LLM as the core of its brains, but combines it with other applications or other components. These components could be databases, components could be REST endpoints, could be vector indices, could be anything else like an external system that it works with, and then orchestrates an entire workflow, right? A workflow could combine multiple little tasks, could combine, sub workflows themselves. But then there is an LLM that is kind of orchestrating through all of these things and then achieving a goal at the end of it. Is probably what the best you could define what an agentic architecture or what a compound AI system is. Uh, so this is kind of the evolution of where the agentic architecture is. Again, it's been what, less than 2 years where we went from like an LLM to an agentic architecture. But again, like remember, LLM is nothing but a machine learning model that generates tokens being English words, right? So essentially what we're really doing all of this stuff is getting words out of an LLM and then somehow figuring out how to call APIs, call databases, call other endpoints from the words that you get from an LLM. So that's essentially what an agentic architecture literally is, right? So
why now? Why can't we achieve this with the bigger and better LLMs? Can't we achieve the same thing, or why do we need it now?
So the good question really is like, why now at this point, right? Like, I think we're getting to the point where, a single LLM is unable to do or is not the best at doing everything, right? To give you an example, right? So if you have an LLM that knows how to, let's say, generate code, and then you ask an English question, and then it is able to figure out the answer for it, and then if it needs to generate code to answer the question, this is what a typical SQL agent does, right? So you ask an interesting question: what were my sales by area last month? That's a question that you would want to ask an LLM. Now there should be an LLM that understands. Okay, you're asking about sales. You're asking about a particular area code. You want it to some kind of split it by that. And then you need something that knows how to understand your database schema and generate a SQL query on top of it. And there is probably another task to it, which is able to take the results that come as a tabular format and then generate a nice looking chart out of it. You're talking about three different tasks, right? Now, they could be the Llama LLM could be amazing at understanding your question, right? But that's probably not the best one at generating the code, right? Anthropic has really good code generation models that you probably want to use to generate the code. Perhaps there is another model that can take output that comes as a tabular format and then put it as a chart, right? Now, in a single LLM system, you would think, hey, the LLM is super powerful. Why don't I ask it to do everything? Now, that's where you get into the point where, first thing, is the LLM the best suited for all the things, right? You have a variety of LLMs right now, which you did not have 2 years ago, where each LLM is now getting to the point where it is good at one thing or a few things. So you want to take advantage of those multiple LLMs, right? So if you split up the overall ask or the architecture of the application separate components, now you can plug in these LLMs for those specialized tasks. That's where you're getting to the point you're answering English question to some kind of reasoning model could be done by a good reasoning model like DeepSeek or GPT-4o. The code generation part could be handled by another LM that is really good at it, maybe from Anthropic. The third part of generating a nice looking pretty picture could be done by a completely different LM, right? So now you have three different agents that are trying to divide and conquer the problem by running with different LLMs, right? So that's one thing. Second thing, trying to scale single LLM to do everything, like question to answer and generating the code and everything, is you're going to hit performance bottlenecks pretty fast, right? I mean, that's probably not what you want to hit, like, and it's great. So scaling LLMs only gets you performance to a certain point, but then after a while, it start hitting the diminishing return. What it means is, yeah, the Llama LLM could really be amazing at doing everything, but then trying to make it generate code and also answer questions, how much more can you do? And fine tuning is also expensive. Second thing, cost, right? Each LLM, even today, LLMs are pretty expensive to even for inference. Inference is when you ask a question, it gives you an answer. These are expensive. These run on extremely high cost GPUs, right? So if there are tasks in your workflow which are not particularly valuable, maybe you have a little bit of performance, you can take a bit of a time hit. You can, maybe that's not the best. You really don't need literally a 70 billion model to to answer a question, right? So you want to be able to split tasks inside your workflow to say, to save on cost, you want to run different set of LLMs or maybe and use different set of endpoints where not everything is going to your Llama or your DeepSeek or your OpenAI, but is going to some of the cheaper LLMs to basically answer those questions, right? And primarily the last thing is really, having different LLMs across these different components, like in a component AI system, it just gives you greater control. What do you want it to
Mhm.
use? How do you want it to avoid answering stupid things, avoid hallucinations, avoid to be able to test and
Mhm.
train better. It's I mean, software fundamentally the same thing. You split up into modular things so you can test and
Mhm.
train and tune better. And that's essentially what's happening with these agentic architectures, as well as you split it up and you specialize it and you tune it at a small. So that's pretty much what is driving this agentic architectures at this point. It's
Mhm.
just that now you have specialized LLMs that can do specialized things. So you're trying to scale up at the module level rather than at a whole application.
Mhm. So it's just not about the capability, it's also about the efficiency and the trust and the
Right.
scalability of it. But what are the few misconceptions of thinking about agentic systems when we wanted to implement it?
So so the misconceptions really is uh, how fast you can build or how uh, amazing it's going to be, because all of us are used to amazing, like these technologies still seem a bit magical when you talk to ChatGPT. It knows so much, is able to answer questions so well, but then suddenly you bring it to your business use case. uh, Often you will be less impressed at how good it is able to answer those questions and things like that. So your traditional software development practices or ability to set those things up properly is still not uh, you're not going to throw any of those practices out. You still need to have those practices.
Mhm.
To give you a good example, right? So maybe let me just walk you through what a typical agentic architecture looks like, and we'll talk
Mhm.
about how what are the places where you have those misconceptions and things like that, right?
Sure,
So
sure.
there's a good picture that I got from this place where they talk about what an agentic architecture looks like, right? So you have the AI agents in the middle, right? These agents come in different flavors. You can think of it as an LLM. Some LLMs are good at planning. Some LLMs are good at answering questions. Some good LLMs are good at generating code. But ultimately, these are a bunch of agents, right? They have long-term and short-term memory.
Mhm.
Short-term memory essentially is the history of what you've just asked, right? You ask,
Mhm.
what are my sales by, West Coast? Then say,
Mhm.
what second question that you ask is, what about East Coast? The short-term memory is the fact that you're still talking about sales. You're not talking about something else, right? A long-term memory essentially is the databases or the long-term data that the LLM can mine on. Maybe you're giving it your database, maybe you're giving it your vector index, maybe you're giving it your documents, your SharePoint, all of those things, right? Those are long-term memory. How you tune both of these to remember, and then come back and answer questions, right? Uh, the way we craft agents are by basically building what are called as tools, right?
Mhm.
That means is tools, essentially, if you go back to your software engineering practices, these are modular components that do one thing and one thing really well, right?
Right.
So the idea is you build tools, code interpreter, search, calculator, calendar, whatever it is, that tool that's specific you're doing. Right now, you probably want to call a REST endpoint, so it's going to be a REST endpoint tool. There is some kind of business logic that you know oftentimes, in a typical application, these are just Python functions or Python modules, really, right?
Mhm.
Uh, and then there is the planning component, which is where what we think of as the control logic. If you wrote your application back in the day with, Java EE or whatever, you would have like a primary controller that knew what all things to call it. I'll call a DAO object to get data. I'll run this business logic component to calculate something. Then I'll call something else to do something else. So that's the planning logic that you're now able to rely on AI to kind of do it, right? Now within the planning, there are different ways of how AI's agents plan. And we can talk about this in the context of design patterns, but essentially there are a bunch of different ways AIs plan to do all of these, and then the AI agents actually do the action. So a typical agentic architecture basically looks something like this. You have one primary orchestrator or a controller that has a collection of tools that it knows about. And then when you define and describe these tools, you basically tell the AI agent, okay, here's a tool to do X. If you want to calculate some kind of date functionality, here's a calendar tool, and it has these functions to be able to do the X and Y and Z, right? The agent knows the tools that are available, so the capabilities.
Mhm.
It knows the question that it's asking. It can mine its short-term and long-term memory to figure out what it is that it's trying to do. And then it uses its planning capabilities to come up with a plan of action of how it's going to use all these tools to achieve a particular action, right? So that's pretty much what a typical AI agentic architecture looks like, right? Now, what are the you asked about missteps and how can I build an effective AI agent
Right.
component over here? Again, it comes back to the same thing, which is, how you still need to have some kind of controller logic to be able to do all of these things, right? None of
Right.
that stuff is going away. Your controller logic, instead of you having to write all of it, you potentially could be generated, but still that controller logic is there. So you still need to define, your modular sense of what are the tools that are there. Like, again, if you go back to software engineering practices, this is exactly what you talk about. Define your functionalities or your business rules in a modular fashion so that it could be used, modular means stateless, single input, single output type stuff. You could be tested independently. None of that stuff is going away. Your tools are essentially that, right? Uh, so how effectively you define your controller logic or your, again, impacts in terms of how well your overall agent is going to perform, right?
Right.
The second thing is about model tuning, right?
Mhm.
We talk about how well is this AI agent, the model's going to work, right?
Mhm.
Now, we talk about performance, the performance is two things over here. Uh,
Mhm.
when I say two things, we talk in terms of the quality of the responses. That is,
Right.
which we don't really worry in traditional software where, you have a QA script, he has an input, he has an output that you expect, and you say, it's all good. Now,
Mhm.
you can't use the same parallel for building an agentic application where you're asking question, expecting an answer. You can't do an
Mhm.
word-to-word match or an accurate match. You have to be able to have some way of judging if the answer is good enough or fit for purpose, right? Uh, and then there is a concept of performance, which is more traditional, which is how fast is it able to answer, right? So we can talk about this in two different ways. So when it comes to model tuning, if your AI agent is performing the way you want it to perform, you might think in terms of, okay, is a GPT-4o model the best thing for my application? Is a Llama model better for my application? Is a DeepSeek model good for it, right? There is no good answer to, which one is better. There is no one thing that works better because a lot of it depends on, what memory or what data you're actually working with, right? So to give you
Right.
an example, if you're building a RAG agent, which is retrieval
Mhm.
augmented generation, right? Uh, if everybody knows or most people know that, a RAG has a component of vector index where all your documents are, embedded and, put into a vector index. When you ask a question, you go search the vector index to pull out the documents. Now, if the way you do the embedding is similar to what your LLM thinks of as an embedding or how the embeddings that your LLM is trained on, chances are, your LLM is going to work better on that. So which means that, if you use a particular embedding model, look for an LLM that has a similar embeddings, was trained on such similar embeddings, it might work better. Uh, LLMs are also extremely sensitive to how your prompts are set up, right?
Mhm.
How you write a prompt uh, will affect how the LLM works. So
Mhm.
it's not easy to swap out LLMs and then expect the same prompts to work exactly with the other LLMs, right? Similarly, uh, it's you might get good 50% performance just by putting in a
Mhm.
brand new LLM. Sometimes just swapping the LLMs might give you performance. There is no good theoretical basis why that happens. There's a lot
Uh-huh.
of it is still in exploratory. So in some sense, you should treat this as of it is there are no set rules, at least just yet, in terms of doing XYZ is the best way to do this. It's a lot of it is still exploratory and whatnot. Uh, and the last thing I'm going to give you is, how do you even reason if doing something is actually improving your performance or not? Right?
Mhm.
Uh, you could do all those things, but then how do you even measure whether this is good or bad? Like in a traditional software, you could say my response went from 20 seconds per call to 5 seconds, so I have a good 80% improvement or whatever, right? But that's not the case over here. So what we typically do in these cases is that you set up a framework to judge how well your agentic application is working. Uh, and then there are different ways you do these judges. One is what is called as LLM as a judge. So which means
Mhm.
uh, you take one LLM to answer questions based on your data and use
Mhm.
other LLMs to judge whether the answers are accurate or not. So you set up an evaluation set, you write your questions, you write your expected answers. So have 20, 30, 40, 50, whatever number of questions and answers that you can think of. Then you run the evaluation set via your agentic application. Your agentic application comes back with answers, right? So there is the expected answer and the actual answer that you got from your application. Now use a third LLM to judge whether these answers are accurate based on what you're expecting on. And then to judge that, then there are like a bunch of different, what do you call, dimensions that we judge. Like, is it relevant to the query? How factually accurate it is? How contextual the answer was? Did it get the answer from the right documents, or did it just wing it and then still get it right? So uh, your your traditional metrics of what is accurate, what is correct, what do you mean by my test case passed is different in these cases. So you'd probably bring in another LLM to even judge those things and develop metrics for what are called LLM as judge metrics. And then you run this thing repeatedly over a period of time, and then you track uh, how well changes that you do in your architecture improves your overall accuracy, and that's how you'd measure if changes are working on.
So if someone is just a lot of moving parts here,
Yeah.
right? It's evolving. Every week you hear something new and best, right? Better than other LLMs and the tools. If someone is just starting based on your experience, where should they focus on? Prompt tuning or retrieval strategies or the orchestration logic? Which one they should focus on?
So your biggest bang for the buck initially is going to be prompt tuning, even today. So
Okay.
let's take a simple RAG application, like a retrieval augmented generation application, right? So you have a vector index or a vector data store, you have an LLM, and then you have your
Mhm.
prompts. That essentially those are the three components that are there that you ask to build an application.
Mhm.
The embeddings to a certain extent are fixed. There
Right.
are three or four like very popular embedding models, BG
Mhm.
embedding, a couple of other embedding models that you can use. But there is not a whole lot that you can do by yourself to change the embedding model, right?
Mhm.
It's not that people don't do it, people do. But if you're just starting out, that's probably not where you're going to start out. On the LLM side, there's not much you're going to change. And I'll come to you what you can change. But right
Mhm.
now, if you think you run your documents through an embedding model, you build up your vector store with the embeddings that's been generated. You hook it up that with your LLM, and the LLM is something like a foundational model like Llama or OpenAI or one of these models, right? That's
Right.
your bare bones RAG application. Uh, that'll probably get to around 50 to 60% accuracy pretty fast,
Mhm.
right? And that's the easy part. When I say, I know this is different,
Uh-huh.
like a brand new architecture. Get into like somewhere between 60, 70% accuracy is pretty straightforward once you hook this the overall setup. The
Right.
struggle starts from when you go from that 50 to or 60 to like 80, 90 or 90% accuracy. That's where all of those things are going to come into play. The things that I was talking about, having an evaluation set, going methodically about changing things. So the first thing that you could do is, if your accuracy is not up to the mark of what you're expecting, change your
Mhm.
embedding model. See if a different embedding model works better for you. Okay, that maybe gives you a 5% boost in your accuracy, maybe 10%. Vector stores come with a lot of metadata stores. So a document
Mhm.
could have additional metadata that could be used in querying things. So for example, the document author or the document refers to places, people, you could use that as a metadata so that your retrieval strategies can use the metadata to answer questions or at least retrieve documents more accurately rather than just simply doing a basic token search, right?
Mhm.
Uh, you might want to add more metadata over there. There are a couple of retrieval techniques that are there within the embedding model. Uh,
Right.
there's something called as hierarchical network search, HNSW, and a couple of re-rank strategies that are there. So you're
Mhm.
talking about taking the retrieval part and then now fine-tuning it and basically seeing if that improves your accuracy. So that's the
Right.
first stage of what you can do. Some of our customers, I've heard customers basically rewrite or fine-tune an embedding model themselves. It's an expensive
Mhm.
proposition, but then if your data is really, really custom, that's where you want to go to. But that is going to be expensive, right? So, and then you go to the LLM side of things. You
Uh-huh.
tune the prompts, see if your prompts can make tuning your prompts to be like a lot more specific. Telling the LLM how
Mhm.
to search for, how what to avoid. That might make your retrieval better. If all else fails, then you can
Mhm.
build a fine-tuned model of the LLM. So you take your Llama model as the base, you fine-tune it based on your documents, and then you deploy the fine-tuned model that is custom to your enterprise. Again, that's an
Mhm.
expensive thing. But these are the steps that you would go from basically a bare bones RAG application to making it more accurate. But you probably your biggest bang for buck is basically tuning a lot of these tunable things, which will probably get you around like 80, 90% accuracy already. But if you really want the final 10%, you have to squeeze the juice, then you're talking about more expensive things. That's essentially what you would do.
Got it. Yeah. There's one question here. I know you are going to cover that as part of the design patterns. The question is about have any design patterns emerged in the early days and that you have seen working well in your experience?
There are some design patterns that people, if you look it up, you'll find a bunch of these design patterns. But again, given I have a background in my software engineering, don't think of as these design patterns as your gang of four patterns of data access
Right.
pattern, factory pattern. These are not those. Okay, these are not set patterns to solve a problem. So these are patterns that people have evolved based on the use cases that they've tried to solve. So don't think of us as these are, hey, I'm going to use a tool use pattern. I'm going to use a planning pattern. No, it's not. They aren't. It's more an experiential thing where people have or practitioners have figured out, okay, this, I'm seeing this problem being solved multiple places, and here's how I've done it before, and hence I'm going to call it a pattern. This is not a problem going to a solution. This is more of solutions coming up as abstractions, and we're calling them patterns at this point. So these are the patterns that are there. If you're really into that. So a reflection pattern is basically, where your LLM, when it makes an API call or when it makes a judgment call, it reflects upon its own choices and then eventually picks one. Now, it's useful where you want your agent or your AI agent to, iteratively analyze outcomes to overall refine the approach, right? Which means that your LLM is basically, hey, do I choose tool X to solve a particular problem? Last time I chose it, I got it wrong. So I'm learning about it. I'm going to choose a different one. Maybe I get it right. Eventually, I'll get it right. It's iteratively thinking through that stuff. A tool use pattern is what I was showing you earlier in this picture, which is I have a bunch of tools that are there. I'm going to describe what these tools do, what the inputs and the outputs are, and my LLM is going to figure out how to use those tools. I'm not training the LLM to tell it to use tool X, tool Y, tool Z in that particular order. You can do that too. But I'm letting my LLMs choose what tools to use. Then there is a planning pattern. This is a little bit of a newer one where this comes from some of the reasoning models that have been become famous recently. For example, DeepSeek is what you call a reasoning model. GPT-4o is what is called the reasoning model. What a reasoning model does is that when you give it a problem, it understands it, it figures out what tools it has what capabilities it has, and then it generates a reasoning of how it is going to do one after the other, as if a human would do or as if an analyst would, right? So basically being able to use the reasoning to figure out what the planning is going to be, and then say, okay, here's how we formulate a multi-step plan and we execute the plan accordingly to achieve that. This helps when you to figure out, okay, what can be built as a tool, right? If you're generating, if your agent who has to solve a problem dynamically, and if that problem keeps happening again and again, you might as well take the dynamic portion of it, convert that to a tool, and make it a more static thing so the agent can actually use it automatically. So you ask it to plan, and then if you see patterns in the plan happening regularly, then you make it a tool. A multi-agent essentially is like a multitask or a tool use pattern where you have multiple different agents that are talking to each other. I've not seen many multi-agent patterns. It seems pretty complicated because who wins if two agents plan to do things differently? Don't know. But the most often used, or at least the most popular thing right now in the ecosystem really is the tool use pattern, where you have multiple different tools that do separate things. And then you train your orchestrator agent that I was talking earlier, saying, here's how you choose what tool to use. To give you an example, you're building a chatbot that has to answer questions from, let's say, your documents, but some of the answers are also in a SQL database, because you have structured data, unstructured data, and whatnot, and you want to be able to answer a question, what are my sales, in this area last year, which might be a SQL question, and then if you say, why did that happen, right? Or why did the sales fall, or whatnot, that might be a memo somebody wrote or an analysis somebody did. If you want to answer a question like that, then your agent should be smart enough to figure out, okay, here's a part of the question that I can answer from my SQL database, which means I'm going to call my SQL agent. My SQL agent knows how to generate a query for that. It's going to get me a query, run the query, and get me a result. And then I'm going to call my vector index or vector database to go and find answers for this particular question. And together can I generate a response back to, right? So that's a tool usage plus a planning pattern that typically is
Mhm.
it's a pretty common thing that happens right now. Like that's where I would say more the state of the art is at this point.
Right.
But yeah, that's what we have.
By looking at the names, looks like these are all industry agnostic patterns, so to speak, right? These are all kind of a blueprints is evolving for across
Yes,
the industry.
that is true. I think we're still in a very industry agnostic phase where, again, remember, like all this is like less than 2 years old, so it's all still evolving, so to say.
So, speaking of the tool use pattern, and can you, go over tools and the frameworks that, the agentic AI landscape thinking about or already started using?
Yeah, sure. So there are like if you've been, playing around in the agentic AI or even like Gen AI place, some of these frameworks would be kind of familiar to you. Uh,
Mhm.
the first one is LangGraph. This is probably the most. So LangGraph is an offshoot of LangChain. So LangChain is probably one of the most popular frameworks that's been around from 2.5 years now, maybe longer,
Mhm.
since Gen AI or agentic AI became a thing.
Mhm.
LangGraph is an amazingly good comprehensive framework that has tooling built in for you to build different types of things, to integrate with the vector index. And again, they have support for almost every vector index that is there out there, like Pinecone, Databricks, Azure, every
Mhm.
vector index database that's out there. You'll find a connector that LangChain has to do that.
Right.
Similarly, they have APIs that know how to work with OpenAI, work with Llama models, with Anthropic models, and a bunch of these. So almost every uh, what do you call LLM that's there, LangGraph or LangChain has integration with all of that.
Mhm.
LangGraph builds on top of LangChain's tooling and abilities, primarily by giving you essentially a DAG, a directed acyclic graph. So to
Mhm.
give you an example, let's say if you wanted to build a RAG application like I was talking about, like a SQL agent and let's say a vector database, right? So you would probably build, you would build uh, using the SQL DB toolkit that LangChain has, you will build an agent or a tool that knows how to take a look at given a JDBC connection or like a database connection, it knows how to figure out how to query SQL. Similarly, if you're assuming you're using Azure Vector DB, then LangChain has framework or tools to integrate with Azure Vector DB. Right?
Mhm.
Out of that, you can build two agents, a SQL DB agent and a vector DB index agent. And LangGraph now gives you a way to basically say, change these two agents into a directed acyclic graph.
Mhm.
Okay. So when you ask the question goes to the graph and the graph makes a judgment call saying, okay, which of these tools do I call? Or do I need to call both these tools? Do I need to call multiple of these tools in a repeated fashion? So that's where the intelligence comes, like, which way do you go in terms of overall process to figure out how to do these things, right? But it's still a tree-based structure type thing. And, you can program and
Mhm.
tell how to use it and in all of those things. So that's LangChain. So it's a very comparatively a mature ecosystem that's out there. The second is more popular framework has become what is called as Screw AI.
Mhm.
This framework comes from some of the big wigs in the AI ML space. Screw AI has a little bit of a different way of defining what tools are, what agents are. Basically, you write a Python function, uh,
Mhm.
uh, put an @tool on top of it, and then
Mhm.
describe what it does. So your application is essentially a collection of Python functions annotated with these @tool API, @tool uh, uh, directive, and then you define agents which know how to use the tools. You say, here's my SQL agent that will use tool X to do this. Here's my business logic agent that uses these 5 tools to do X, Y, and Z. And then out of all these agents and tools, you create a crew. And that's their
Mhm.
term. Set up a crew that has all these agents which have all these capabilities. And then you tell the crew what the ask is or what the goal is to do something. And the crew will basically figure out how to orchestrate all of these things and then run those things. Part of it could be code generation. So you have a code generation agent. Uh, Crew AI will spin up a Docker container, run the Python code, run something, get the output of it, gives you the output back. So that's how Crew AI works. But both these frameworks rely on you to set up the prompts correctly to both
Mhm.
describe the tasks, to describe the agents, and do all of that. One of the more newer frameworks that's out there is what is called as DSPy. Uh, DSPy takes a little bit of a different approach compared to LangGraph and Crew AI. The difference comes in DSPy's philosophy is that uh, prompting is actually an engineering task and not a language task. So right now, as we talked about, like prompt tuning is still the best effective way for you to get output. DSPy turns it over and says, no, you just tell me what you need to be done, and you can train DSPy to generate prompts on the fly. So these are called dynamic prompting. So you say DSPy, all I'm expecting is I'm going to give you a question, you're going to give me an answer. And here's my sample questions and sample answers. And you train DSPy to generate the appropriate prompts for you. So the DSPy model is actually it's similar to how PyTorch is, where you train the model to generate the prompts rather than write the prompts by yourself and expect the prompts to run. Right? So the DSPy takes a bit of a different approach, but then DSPy is a bit new. You can use all these things in conjunction. Crew AI also uses LangGraph utilities to a lot of this stuff. So it's not as if it's one or the other. It's a combination of all of these things that is typically what is used in the enterprise at this point.
There's so many options similar to the components, which makes it an architecture, right? A team really have to work on, productionized version of it. How do they choose the right stack for them so that they can focus not on the tools, but, delivering something to the
At this
production?
point, I think you again, like, I'm not somebody who gives you definitive answers on everything, but I'm saying all these are still new. All of them are interoperable, and none of these are like set in stone as if like you cannot move from one thing to the other. Ultimately, these are basic Python functions. It's easy enough to move from one thing to the other. What I would try though is try out a few things. Start small, build a POC, choose one of these tooling or API frameworks to do that. Get your deployment running, and then iterate on top of it. Like that's the only way you can figure out what is the right uh, choice that you make. Both in terms of the frameworks, in the LLMs, the overall design. Like there's no other way but to kind of iterate and try it and test it out.
Yeah. I have few questions for myself to cover audience intent there. But before that, do you want to cover the deployment and tracing too?
Yeah.
Or?
Yeah. So like once you build your application, right? So ultimately, when you build a RAG agent or when you build the SQL agent or whatever it is, the thing that you're deploying is essentially this model, right? A model that knows how to like your like for example, like if this is your orchestrated thing that you build that knows to use tools and whatnot, the stuff that you're deploying is this orchestrator object. Okay. Uh, the orchestrator object is typically packaged into something called as MLflow. You could package it as a PyFunc in MLflow. So that's your model. Your model is you deploy that on your deployment endpoint. That ultimately becomes like a REST endpoint, and then internally it'll make calls to the LLMs. It'll retrieve data from vector indices, send that data onto the LLM to answer the questions and things like that. So ultimately, you will need some framework like MLflow for both model packaging and also tracing, because tracing is a very important thing over here. Because oftentimes you do not always know what answer you're getting from at the LLM. What is the data that's being sent to the LLM and what is the response you're getting back from the LLM. MLflow gives you a way to kind of set up these tracing endpoints. That way, you can see when you ask an English question, like what is a prompt that is actually going to the LLM for which it is generating the SQL code, or what is a prompt that's going to the LLM where it's giving you the answer. So ML flow tracing becomes an important. And eventually, when you want to productionize this, you need some, model serving providers. Either you do it yourself on an EC2 instance, or you use something like Bedrock or Fireworks or Databricks or whatever as your model serving endpoint. So eventually, to scale, you need like if for example your chatbot is internal today, but suddenly it starts fielding questions from 1,000 users. To be able to scale it, you need a model serving provider that can scale up pretty fast. Again, like these are not trivial decisions. When you talk about productionize something, you need to think about can your serving endpoint scale that fast? Can you like take the model and deploy, federate it easily and things like that? So things that you need to be aware of as you move the journey from, initial development to production.
So I think that's overall I think structured content that you have. I have a few questions. We have another 4 minutes here. What was a big aha moment for you when you heard about Agentic and when you started implementing this?
I think the big aha moment literally is like, how quickly you can get to 50, 60% accuracy where it is answering questions that seems magical, and then how
Mhm.
painful it is to go from there is typically if you come from a software engineering background, you know exactly, okay, I'm going to go tune my database, I'm going to tune indices, I'm going to tune this. But given how new these things are and how opaque some of these things seem, uh, tuning is a bit of a challenge in a lot of these things. Like, you don't always know what to tune, how to tune, but then the effort that gets into making them work properly the way you want to scale it is not trivial. But then it seems trivial to anybody who's used ChatGPT or outside because, oh, it's able to answer everything properly. Why can't you make it answer everything from my database or from my
Mhm.
documents? So yeah.
So there's a question from audience here. Are there any data security challenges in deploying Agentic AI
Yes,
application?
there are plenty of data security challenges that you will face with deploying something like an agentic AI. Even if you're deploying, let's say, for internal facing users, internal applications, uh, hallucination is still a big issue. There are no apart from like prompt tuning and things like that. No, there are a few techniques to kind of minimize hallucination, but not completely avoid it. Uh, One way is when I talked about evaluation set and like training and like testing the model repeatedly. That's one way you can judge is if it is giving you bullshit answers or answers that it should not give you. That's one way to figure out whether it is hallucinating. Uh,
Mhm.
like you can restrict in terms of what vector indices or what databases or what tables it is allowed to search. That's one way to figure
Mhm.
out whether it's not allowed to look at a few things. So those are guardrails that you have to set up outside the LLM to kind of
Mhm.
prevent it from like giving out information that it's not supposed to. Uh, but the LLM as such, like you really, unless you fine tune your LLM to do something very, very specific, the LLM to a certain extent, is a bit of uh, a free agent to tell you what you do. So data security is definitely a challenge, and that's something you need to think about it upfront, either in terms of the way you set up your prompts, the way you set up your data access, the way you set up your testing scenarios to catch for all of these.
Cool. So I know we have another minute here. One last question. By keeping tech leaders in mind, so how do they prioritize from the exploration to the implementation when everything is evolving so fast?
I don't know if there's a good answer to it, but you kind of have to move with the times. You like most of the customers that I've seen are still like a couple of years ago, everybody was exploring. Now we are seeing a bunch of these applications get into production, primarily in terms of internal facing, where there is not a huge liability of getting few things wrong, right?
Mhm.
So that is where we are at this point. So we're probably, but everybody knows that they're here to stay. This is only going to get better as you go on. Uh, you're getting to the point where the productivity gains are real. So you cannot not invest in building these things. You have to. It is just a matter of taking small steps, small guarded steps, and uh, trying to see how much of bang for your buck that you can get from these things. And eventually these things will mature, these tools will mature, and these frameworks will mature. So it is just a matter of being in tune or in line with where the industry is, rather than trying to catch up like 2 years later when everybody's just moved on.
Awesome. This has been a great deep dive session, Satish. Thank you very much. Thank you, everybody, for joining. We are on top of the hour here. If you have more questions related to the tools or patterns or any implementation advisory, feel free to reach out to Satish Terala or TechGrid, me and anybody from the TechGrid. So we would be happy to respond to that. Really appreciate Satish. Thank you very much.
Thank you. Thanks, it's nice talking to you.
Yep. Keep experimenting. Bye bye.